All right, Technical Manual 650, Central Boiler Plants approved for public release distribution unlimited Headquarters Department Army 1989. Chapter 4, Water Treatment for Boiler Plants. Objectives of water treatment. This chapter is an introduction to the boiler water treatment. The boiler water requires the treatment to protect both the boiler and distribution system. Professional help will occasionally be required for to solve the specific problems. Further assistance may be obtained by the U.S. Department of Army Engineering Housing Support Center and Fort Belvoir, Virginia 22060. This material with the chapter is designed to acquaint the operator with the reasons for the treatment, technical availability, four primary reasons for technical water for treatment of the boiler water. Minimize corrosion of the boiler distribution system. Corrosion of steam distribution is a result of the carbon dioxide oxygen released from the boiler water. The carbon dioxide condenses the form carbonic acid, which combines with the oxygen to act as the distribution system pipeline. Iron and copper particles have been returned to the boiler. Suspended solid waste to collect as the boiler scale. Sludge promote corrosion and boiler leaks. Distribution system piping and energy loss of steam, hot water, additional raw water must be treated. Replace water and steam loss. Additional loss. Adding the water treatment causes treatment costs quantity impurities. Add to system. Figure 1 illustrates oxygen pitting and of the condensated pipe. B. Minimize boiler scale deposits. Boiler scale deposits accident insulation can result with the overheating of the tube. The subsequent tube failures. The deposits also reduce the heat transfer of the tubes, causing higher boiler existing gas temperature below boiler efficiency with the promoting corrosion, allowing the concentration of impurities under the scale. Figure 4.2 illustrates the boiler tube, which has failed to do the scale, improve the efficiency operation as noted above. The central boiler scale and system leakage due to corrosion helps to prevent the plant's operational efficiency. Effective boiler water treatment also reduces the energy loss of the blowdown. Treatment chemical quantities reduce the imperishable energy, saving the return realized with the blowdown and reducing condensating return quantities increase. D. Control carryover. In steam boilers, water may be under some condition to leave the boiler with the system. This can result in the deposits and superheater tubes, and shown in Figure 4.3. Piping in the turbines corrosion and encourage under the deposit. Such deposits water carried over the stream can also lead to water hammer, which can extremely damage the piping and equipment. 4.2 impurities of absolute pure water is now found in nature. The impurities of the water include dissolved gases, chemical compounds, solids, suspended solids. Some of the impurities can be seen, while others detected by taste, odor, and still, while others detected by laboratory tests. Potable water contains impurities that make it unsatisfactory for boilers to using, including hardness, components, involved minerals, alkalinity, dissolved gases, suspended solids, and oils. In controlled concentration for the impurities. Only parts per million ranges can cause major problems with the concentration of oxygen and parts per billion corrosion of problems. Hardness in the water results with the presence of the calcium and magnesium, which may be deposited at scale. Most of the calcium and magnesium, either in boiler and boiler water treatment systems, is combined with either carbonate or bicarbonate, is referred to as carbonate hardness. The hardness is generally expressed in time of the equivalent calcium carbonate. Hardness is then may also be combined with sulfates, nitrates, and or chlorides, in which cause they are referred to as non-carbonated hardness. Calcium and magnesium are positively charged ions, cations, which dissolve in water. Carbonated sulfite are negatively charged ions, called the anions. Table 4.1 lists some of the cautions in anions, which are commonly used, common to the boiler water. Table 4.1 common cations and anions. Cations, A plus, aluminum plus plus plus, calcium plus plus, ferrous iron plus plus plus, hydrogen plus, potassium plus, magnesium plus, sodium plus. Negative ions, chloride, negative CO3 carbonate, HCO3 bicarbonate, HCO3 bicarbonate, phosphate, PO4, sulfate, O4 sulfite, CO3, silicate, CiO3. One, calcium carbonate soluble with the common natural water. The common decompose with additional heat and increase in pH to form calcium carbonate, carbon dioxide. The reaction is known as calcium with hydrochloric bicarbonate equals calcium carbonate carbon dioxide, and water. Figure 4.1 shows a condensated pipe corrosion. Figure 4.2 shows a boiler tube fuse failure caused by scale. Figure 4.3 shows a superheated tube using carryover deposits. Alright, calcium. Calcium carbide formed in the above the reactions have the low suitability to forms the tenacious scale with the carbon dioxide carried with the boiler and the steam. When the steam condenses, the carbon dioxide is dissolved with the condensating, forming a weak carbonic acid solution. The corroded metals in the condensate system and anti-titanium condensated with the dissolved metal. Calcium sulfates varies forms the calcium sulfate scale from found in the boiler system. The most important is gypsum calcium sulfite. With 2 hot water molecules, the soluble gypsum increases the temperature, reaches the approximately 100 degrees Fahrenheit, then gradually decreases. The scale has more than 100 times the suitable calcium carbonate normal temperature. Maximum magnesium bicarbonate. Magnesium bicarbonate differs from calcium bicarbonate that it decomposes in additional heat in the form of magnesium hydroxide and carbon dioxide. The reaction is magnesium hydrochloride equals magnesium hydroxide and carbon dioxide. The magnesium hydroxide may form a sticky sludge deposit boiler scale in silica in the water. The magnesium hydroxide will react in silica to precipitate magnesium silicate, which may be removed as sludge. 4. Magnesium chloride. Magnesium chloride is very soluble. It reacts with water metals and with water metal interface, producing magnesium hydroxide, hydrochloric acid. The solution is known as magnesium chloride plus water equals magnesium hydroxide and hydrochloric acid. Hydrochloric acid in gases which can leave with liquid water with the corroded with the boiler just above the waterline. Silica, and silicon dioxide. Silicon dioxide is found with abundant nature. Common forms of silica include sand, quartz, and silica. Boiler water feed water participates in form of a hard glassy coating of the boiler surfaces, and boilers operating above 400 psi. Silica vapor is carried over the steam deposit of the turbine blades and piping. In treatments, boilers operating below 400 psi. Silica is not troublesome because the silica vapor is not formed. Phosphate treatment will prevent the calcium silicate with the forming scales, combining calcium with sufficient alkalinity, and which keep the silica soluble. Excessive concentration of silica can be limited to extreme temperature and continuous blowdown. Alright, iron and other suspended solids. In erosion, iron corrosion predicts the probable single largest cause of deposit problems in boiler system condensated systems, which have been attacked with carbon dioxide. Oxygen, a major source of the iron deposited in the boilers. Iron is the source of this fine with the suspended solid. Other suspended solids which may enter the boiler for porous deposited low fuel areas include copper, mud, sand, silt, clay, dirt. Localized corrosion damage occurs at these deposits. The dissolved gases, oxygen, carbon dioxide. Water that comes in contact with will absorb the oxygen. Carbon dioxide. Rainwater will typically contain 9 parts per million of dissolved oxygen, which may impurities will be acceptable to this level. Oxygen is not, and treatment must be applied to reduce the oxygen levels 1,000 times. Oxygen level of less than 7 parts per billion are necessary to avoid pitting and corrosion common of the oxygen attack. Carbon dioxide may either from air from the reaction of carbonates with water react, and carbon bicarbonate plus H2O equals carbon dioxide, or two oxygen hydrogen molecules. The reaction creates an important result with the host carbon dioxide reproduces the last part present with the carbon corrosion problem with the condensated system. The carbon dioxide oxygen are more corrosive combination that are separately. Second, hydroxide being proposed with the use of alkalinity and calcicity of the water has been increased. Alkalinity and calcicity. The alkalinity with the water tells the amount of acid the water can neutralize. Alkalinity results from the bicarbonate, carbonates, hydroxide, other negative ions present in the water. Total alkalinity, M alkalinity, is the amount of alkalinity that will react with the acid pH of the sample to produce the methanol orange endpoint. Approximately 4.3 pH at pH. The P-alkaline amount of the alkaline will react with the acid of the pH of the same, reducing the phenethanol ethylenine endpoint approximately 8.3 pH. Alkaline is reported at parts per million with the calcium carbonate, while the causticity is proportional to the total alkaline-related hydroxide ions. Maintaining causticity will limit the boiler water important to avoid corrosion, but the acid promote good reaction between impurities. Maintaining impurities with dissolved solids ensure the desired relationship between calcium phosphate, alkalinity, causatic. It must also be desired to limit the cause corrosive attacks or carryover. Increasing causticity decreases the amount of hydrogen ions and acidity of water, as we've been seeing in the following discussion about pH. pH measures the acidity, the alkalinity of the water. The test specifically measures the concentration of hydrogen ions in the water. A very small portion of pure water ionized equals parts for the hydrogen acid or hydroxide alkaline ions. The reaction equals H2O is plus hydrogen and plus a hydroxide. There will be 1 times to the 7 to negative 1 times negative 7 10 to the negative 7 grams per liter of each ion. Pure water, thus said to be pH of 7. Values of pH less than 7 are said to be acidic, not more than H plus ions, which values greater than 7 are said to be alkalines containing more than hydroxide. pH scale with a logarithm: pH 5 and 10 times the acidic pH 6, while pH of 4 is 10 times more acidic than pH of 5 and 100 times acidic with the pH as per pH 6. It's important considering adding strong acid to the system because of the 1/10 of the nitrogen sulfuric acid will amount to 100,000 times the acidic neutral water. Add 1 gallon 1/10 of the nitrogen sulfuric acid system of 100,000 gallon capacity will double acid in the system. The pH water is very important for the factor controlling corrosion. Very small changes in the pH can significantly affect the solubility, reaction, precipitation of the impurities. Table 4.2 illustrates the relationship between pH and normality of the hydrogen concentration. Water pH. 4.3 results in reactions of boiler impurities. Scale sludge corrosion carryover. The result of the boiler water impurities. Reaction impurities are discussed below. The scale and sludge may form either dissolved suspended solids. Steam boiler impurities are concentrated where the boiler water steam is produced. Given the temperature, pressure, and the pH fixed with the amount of the water can hold the solution only fixed amount of any given solution substance. Then this is called solubility of substance. Water can hold a great quantity of soluble substances like salt, while less soluble substances like calcium carbonate are not held in large quantities. While if water holds too much calcium and bicarbonate ions, the excess calcium carbonate will precipitate over the either scale of the metal surface of the sludge. By the boiler water treated as phosphate, the calcium hardness precipitates the calcium phosphate. Sludge becomes calcium phosphate and cells less soluble. The calcium carbonate, the sludge, and can be removed at the bottom of the blowdown. As scale is formed, it may collect suspended sludge or solids such as iron scale, silica. Typical scales may include calcium carbonate or calcium sulfate, calcium silicate, magnesium hydroxide. Scale may encourage corrosion, may range from the soft purest and easy to remove, hard or extremely difficult to remove. The thickness and insulating effects of the scale will vary. The water treatment is used to minimize scale deposits, reducing hardness and other solids. External treatment and blowdown. Internal treatment is then used to promote favorable reactions. B. Sludge is accumulation of suspended solids. These solids may have been entered in feed water, precipitating the hardness of the iron end of the water. Sludge is found in the less turbulent section of the boiler distribution system. It must be sticky unless removed regularly. It may be settled on the metal surface to form a scale. So the sludge may cause a plunging in the water. Wall headers, tubes, and metal mud drums, blowdown lines, gauge glasses, connections. Calcium phosphide, iron, rust, silicate are common found in sludge. Internal treatment dispersants like titanium is used to keep sludge finely divided, in fluid, and blowdown is used to remove the sludge. Alright, C. Corrosion. Iron is found with the natural state is also oxidized in compound F2O3, F2O, F2O4. Corrosion is an electrical chemical reaction nature with the returning process metals like steel and copper and zinc to their natural state. Iron and steel boiler parts give the two electrons is to give its solution F2 plus 2 plus iron. The iron, when iron goes to solution and called the anode, damaging corrosion will not occur unless the electrons damage and the iron removed from the steps is removed from the steel of the oxygen or hydrogen. There are where the electrons are removed by called cathode. The fact that water can only hold any of the certain amounts of the ion solution limits corrosion. Fortunately, oxygen and water F2 on hydroxide ions called ferritic hydroxide, which precipitates out of water. This reaction is known as 4F2 oxide equals 2H2O oxide F2 or ferritic oxide. This reaction occurs in both cold weather with hot water that allows the more iron iones enter with a high temperature. Ferrous hydroxide returns into water from the magnetic iron oxide or magnite. Heating surfaces of the boiler use the black will use unsuitable black oxide precipitate out of the water. The reaction with ferric hydroxide can give up the water in the form of insoluble peroxide hematite, although may intermediate reactions occur with the final reaction. Three iron molecules and two oxide molecules make F2O4 and plus 2H hydrogen, 2 hydrogen. Ferric hydroxide can give up the water insoluble ferric oxide hematite, although many intermediate reactions occur with the final reaction. 2FOH3, F2O3, and 3HTO. The product boiler's distribution pipe of the rusting, both external and internal water treatment is to keep oxygen levels in parts of per billion range less than stop corrosion, preventing electrons from being removed from the steel. Corrosion can also be damaged to the idle boilers if they are not protected. Maintain line pH and deaerating water. Pitting is corrosion small area of the metal surface often caused by oxygen in the water. These areas with the more metallurgic defects can cut and scratch the crevices either of the metal surface under scale with the sludge deposits. Oxygen reacts with the ferrous ions with the form of the insoluble ferric hydroxide. Ferric hydroxide forms a small hood or a tubular cool over an area. Includes the electrolytic current that flow through the metal. The current causes the more iron that converted with the ferrous ions goes through the oxygen react with the ferrous ion, causing more high ferric hydroxide to be precipitated. This action may contain and continue the metal completely, though the pits are usually started with the boiler and ideal the pitting of the more destructive type of the corrosion that occurs with the boiler distribution system. 2. Condensing, lining, grooving. Carbon dioxide leaving the steam boiler condenses with the steam of the carbon dioxide will be formed as shown below. Carbon dioxide and 2 water molecules equal hydrogen carbonate. The weak acid will lower the pH, condensate the more, make hydrogen ions available to encourage corrosion. Ferrous items will remove with the steel and return with the boiler pan. Ferrous bicarbonate, or the rust particles ions typically removed at the bottom of the condensation pipe, causing the general thinning of the pipe wall. Grooving along the bottom of the pipe of the corrosion is the most active, where the steam condenses oxygen, either the boiler or the raw water entering the distribution system, e.g. through a leaking heat exchanger will add the corrosion problems. Raw water leakage can cause scale and sludge problems in boiler corrosion condensating return systems. 3. Copper and brass corrosion. Copper and brass corrosion, electrochemical corrosion, preventing of the type of the corrosion, and it's important to protect the distribution system heat exchange with exposure to excessively high, low pH levels. 4. Catastatic corrosion, catastatic embrittlement. An excessive amount of hydroxide to the boiler water can cause a higher concentration of hydroxide to occur with under the scale deposit. Mechanical joints can result in the pitting of the corrosion. Causatic embrittlement. Causatic embrittlement is a specialized type of the corrosion occurring with the stress points of the boiler. Once common, the boiler failure. Improve the fabrication techniques before better the water treatment have been made is rare. Carryover. In the steam boilers, pour boiler water and produce carryover of water deposits within steam. These water deposits will contain impurities found with the boiler water. The contamination of the carryover the cause of the following blockage equipment. The corrosion carryover occurring in three ways. 1. Foaming. 2. Misting. 3. Priming. Foaming involved the production of the foaming, the liquid steam phase, which is carried out with the same high concentration to dissolve suspended liquid solids, including alkalides, oil, fats, grease, organic matter, can cause foaming. The misting of the characterized fast rising of the steam bubbles, which burst and center water and steam line. Priming involved the sudden surge of the boiler water level, causing some of the water to be carried out over the steam. Mechanical cause of the primary conclude the carrying of water level to the high, uneven fire distribution load character of the boiler design. Priming is also aggravated the impurity for the limited. The mechanical cause may require the redesign of the boiler steam drum internals, insulation steam purifies, lowering the boiler water level. The better firing methods of the better boiler load regulation. 4.4 controls impurity. The treatment of the boiler water falls within three areas: external treatment, internal treatment, and blowdown. External treatment involves the various treatment of the makeup of the water, remove the hardness, alkaline, dissolved gases, other impurities before the water enters the boiler. The internal treatment involves the introduction of the chemicals directly into the air, either the boiler feed water just before it enters the boiler and into the boiler drum itself. Impurities with either the steam boiler from the source of the concentrated as steam produce. Blowdown involves the intermittent and continuous removal of the concentrated boiler water sludge. Combination external treatment, internal treatments. The blowdown must be used in excessive control of the impurities resulting in scale sludge corrosion carryover. External treatment. External treatment equipment chemicals are available to remove the impurities from the water before it can be entered the boiler. External treatment is discussed in Section 2 of this chapter. Remove the impurities before they are boiler. Most effectively way to protect the boiler, reduce the water problems. Effective external treatment also helps reduce internal treatment costs and improve the boiler operating efficiency by reducing the blowdown requirements. Internal treatment. The purpose of the internal treatment is to prevent any problems with the problem distribution system caused by the impurities remaining in the external treatment. The many methods of internal treatment and use of the Army use carefully controlled boiler water, alkaline phosphate treatment, remove the hardness and organic dispersant conditions, suspended solids, the chemicals. Used for the internal boiler water treatment and combines with rapidly available. The most common cause of the use in the Army blowers, the caustic soda, the sodium phosphate and quibacotanium sulfide. Sodium sulfite is used to remove the dissolved oxygen when steam plants for neutralizing amino ions are used to control condensated line corrosion. The amount of the internal treatment is based upon maintaining the chemical specified control limits. Continuous feeding of the chemicals recommended for the best and consistent control. Blowdown. Steam leaves the boiler with the dissolved solids concentrated with the remaining water. If the concentrates were allowed to continue with the control of the dissolved solids with water, would evaluate the precipitate out of the scale of sludge and carry over the result. Preventing these problems, sludge is remove the intermittent bottom of the blowdown. Dissolved solids remove the continuous intermittent blowdown from the boiler water. Rate of blowdown. The amount of feed water to the boiler during the given period is divided in the amount of blowdown during the same period given the number of the times the feed water has been concentrated in the steam boiler, called the cycle of concentration. Simple concentration blowdown calculations are presented in Appendix D. The rate of the blowdown is controlled by such a concentration that is high as practical. The concentration that can safely carry dependent on particular installation determined the optimization concentration for given plant. Concentration is gradually built with the boiler operating with a typical load profile. Simple samples of condensed steam boiler water are taken for the analysis. At the same time, concentration of the dissolved solids of the boiler water at the time of the carryover the first appear of the steam attempts to establish the upper limit of the concentration. Normally, however, it is not necessary to perform these tests for the average condition blowdown rate should be sufficient to maintain dissolved solids between 3,350 parts per million. Additional rate with the blowdown most sufficient prevent sludge accumulation, prevents the excessive acidic silica. 5% blowdown, 20% or 20 concentrations are typically plan good external treatment. In the case where there is possible, consult with the operating agency. Manage the amount of blowdown must adjust in accordance with the load. As the boiler load increases, the blowdown should decrease proportional. If there for any reason the percentage condensate being the return from the boiler drop through that to make over the water is needed with the same load, a higher rate of blowdown may require maintaining proper limits. Continuous intermittent blowdown. Blowdown can be performed either continuously or intermittently. Continuous blowdown is generally preferred because it allows the closer control of the boiler water solids, energy saving through reduced blowdown quantities. Blowdown can be controlled either manually or automatically based on boiler load by using conductive monitoring, actuating throttling valve. The automatic blowdown control save valve, the treatment chemicals reducing boiler makeup requirements. Automatic blowdown controls can also be justified blowers as capacities of 10,000 pounds of steam per hour or more. Intermittent blowdowns less desirable, less economical because the solid concentration allowed to fluctuate about the optimum level. However, the reducing equipment requires the justifying intermittent blowdown small boilers relatively low load requirements. 3. Location of the blowdown. The location of the blowdown is a factor considered to determine the optimum blowdown rate. At the bottom of the blowdown is necessary to remove the settled sludge. Frequent blowdown of the blows the short duration and more effective sludge. Remove the occasional blow of long duration. Long blows from the bottom constant connections should be avoided. The danger of starving, overheating generation tubes, loading of the control of dissolved solids of the impurities normal taken near the water level. Water is removed from the nozzle located about 6 inches from the normal operating water level to the area away from the feed water inlet. 4. Economics of blowdown. In the rate of the blowdown, except for the high heat and fuel, the treatment chemicals, waste, water, all waste, the most efficient, significant loss that comes from the heat is lost with the blowdown. Up to 2% of the total boiler heat input may be lost to the blowdown. Heat exchanger will return part of the heat to the making of the water. Recommended for all the boilers operating with a continuous blowdown. The high cost associated with waste fuel can also be justified upgrading the external treatment equipment for the reduce the blowdown requirements. Factors affecting blowdown water treatment. Many of the mechanical activities, including operation deaerators, water sifter, blowdown systems, affect the boiler water treatment. Efficient operation of the deaerators, venting, and the corrosive gases will help control corrosion in the boilers and condensated return system. Reduce the chemical treatment requirements. Efficiency operation of water softener will assure the almost hardness and feed water through the reducing internal treatment requirements. Proper control of the blowdown will result in saving the treatment of the chemicals as discussed above. An additional mechanical maintenance effect of the boiler water treatment program. For example, tightening the distribution system with a light stream, condensating leakage result with a minimum makeup of the requirements, consequently less chemical treatment. The Ames boiler water treatment is achieved, therefore controlling the mechanical treatment, maintenance of the chemicals. Technical assistance. Technical assistance available for operating agency commanders for the training, personal control of the chemical treatment, testing procedures relating to procedures such as return line corrosion, deaerator operation, and any other problems pertaining to water treatment. 4.5. Water treatment requirements. Proper water treatment is necessary to prevent scale sludge and corrosion from the boiler water distribution system. The type of the extent of the treatment required to determine the nature of the raw water, type of the boiler, and the use of steam or hot water produced. Boilers are classified in low temperature water, medium temperature water, high temperature water, low pressure steam, high pressure steam. Treatment requires steam boilers. Central boiler plants should be equipped with external treatment systems to reduce the sludge and scale potential of the boiler water. The deaerator is capable of delivering feed water the oxygen content with all the operating loads. Where external treatment is not available, special precautions must be taken to blow down the boiler sufficient to keep the suspended solids at low level, preventing the sludge in the form of the boiler surface to keep the silica concentration long enough to prevent deposit. Water treatment has the high pressure steam boilers consists of the caustic sodium sulfite, sodium phosphate, tannium, and must be eliminated with the control limits of the deaerator. Should be operated with the give of dissolved oxygen values in the feed water of the 5,000 cc's to zero oxide per liter, 7 parts per billion with the boiler. Water sodium sulfite residuals should be maintained. Low pressure steam boilers require water treatment based on size, the makeup of the age, and the type of the water, the local makeup of the water, characteristics, scale, corrosion problems. When caustic soda, sodium sulfite, phosphate, tannium, and edge, low pressure steam boiler treatment is generally controlled with the same limit high pressure boilers. Desired boiler water limit steam boilers producing saturated steam. The heating of the humidification on at least 3,000 psi Gs are given below the comments of these limits of special case are presented with the following paragraphs. Caustic, total alkalinity, phosphate, tannin, dissolved solids, suspended solids, sodium sulfate, silica, dissolved oxygen, and iron. Maximum value not be achievable in practice and to maintain the caustic and suspended solid limits when they override the total alkalinity dissolved solid criteria. The current ABMA guidelines totals dissolved solids all out in concentration of 5,000 parts per minute per million for the boiler producing saturated steam and less than 250 psi for the heating of the boilers producing superheated steam following the manufacturer recommendation for dissolved solid steam. 3 for boilers designed to operate at the moderate low heat transfer rate, suspended solid limits of 300 ppm per 300 parts per million with the acceptable steam used for the heating Heating, and if excessive sludge does not develop, the generally include the boiler generating steam with approximately 50 psi, especially for the construction proper of the mid-1970s. The boiler producing high-pressure steam, the steam that usually drive the turbine and other processes much lower between the limits of between 10 and 25 parts per million. Recommended the following manufacturer recommendations. Solids are increased with the boiler by the use of the phosphate symmetry of paragraph 47b. Phosphate ions, which introduce the internal combine with the residual calcium ions and under conditions of high pH to form the tricalcium phosphate. Since tricalcium phosphate is insoluble or retainable, the boiler with it is a sludge suspended with the solid, which must be removed or by blowdown. 36 to 60 parts per million phosphate residual noted of the previous page with the solid sulfate phosphate present over the above required to be precipitated out of the calcium, sometimes excessive phosphate, since each of the parts per million of the calcium essentially reacts to the 1 part per million of the suspended solid. It is important to size operating softening equipment as to minimize residual calcium hardness, therefore internal phosphate requirements. 4. Low pressure cast iron steam boilers are not treated in scale formation. Is observed inhibited sulfamic acid is required to remove the deposit. For steam boilers used in conjunction with the cascade type of the hot water distribution, the limits are pH, calcitic sulfide, sodium sulfite, recirculating hot water distribution system, and pH and hardness. 6 wind water tube. The boiler is 35,000 pounds of steam per hour. The greater capacity operated with the high loads. It may not be stable for the boiler water and use may leave with the furnace tubes deposit in case the preferable operated with the tannin and lanolin dispersion may be used instead. 7. Any anti-foaming agents may be necessary in some cases. 8. The low-capacity steam boiler rated with a capacity less than 60 horsepower or 1,500 pounds of steam per hour need only be treated with the caustic soda. A pH of 10 to 12 should be maintained. Boilers rated at 10 horsepower need not to be treated unless warranted in local conditions. 9. In boilers operating less than 300 psi, silicated with the scales mostly, is calcium silicate softening of the water move the calcium ions generally sufficient of the control of the type of the scaling. 10. 150 parts per million limited the silica suggested guideline. However, the levels maintained provided with the caustic maintain high levels enough to ensure silica solubility. The maximum silica level is acceptable. Individual installation must be determined by the boiler plant. Should not exceed the level at which the buildup of the sludge scale occurs. B. Treatment requirements of the steam condensation system. With the steam system where the amine treatment is a commonly justified minimum condensation limits maintained with a pH of 7.5 to 8. Higher values of the pH may be required at the same point of the system in order to maintain the limits. Treatment requirements of hot water treatments and medium temperature water boilers. Treatment requirements of hot water are different greatly than those of steam systems. These systems are closed without the makeup of the water needed to replace the water lost with the pump glands and valve stems. This make up the requirements of small accumulation impurities or small blowdown rarely needed. Making up the requirements of even large systems should not exceed 200 to 1,000 gallons per day. All makeup of the waters in truth, the hot water system must be treated to remove hardness of the water. Softening system should normally consist of dual zeolite tanks, brine solution tank, manually operated manual port control valve, the bell alarming water meter, water distribution manifold. The aerator is not required. Sodium sulfite is used to remove the dissolved oxygen. The desired boiler water limits of the hot water system are pH, sodium sulfite, hardness. D. The treatment requirements of low temperature boilers. Low temperature boilers were treated with noted in paragraph C with the hot water treatment, medium treatment temperature water system. Alternate, although the low temperature water system may be treated with the borax nitrate or copper, or if the copper piping is present, borax nitrate with copper inhibitor. The desired boiler distribution water limit is alternate to 1,500 to 2,500 parts per million of borax nitrate. Section 2, Equipment and Chemicals.